Heyo, and welcome back. Tonight we're just kind of hanging out, talking about a couple of things I've been thinking about for a little bit, then formal, and then continue work on our vt100 video game screen, and also just general terminal for our virtual processor. Oh, I've been experimenting with changing the cursor position, and unfortunately, while it's easy enough to change it, not so easy to read it back. And I think I'm having the same trouble this time as I had last time. And part of the trouble is my big head's in the way. Let's see. All right. There we go. Now we can see. Ain't that lovely? All right. So reading the cursor position back in, I think I'm having the same problem I was having before with the output, that it was going by too fast. And I was losing the output, and I think in a similar way, the response coming back for where is the cursor position is coming in, and I'm dropping characters there. I only get the last R. This second one is a different print. So, yay! Thanks for joining. All right. So, let's see. And where we think the problem is we're not synchronous on receiving the bytes like we were in transmitting them. And while I set up a queue for the transmit side, you know, I'm not going to be doing this a lot, I don't think. Famous last words. So I'm just going to make it synchronous on the input. So to do that, we're going to bring open the source code, which I don't have open, of course. Oh no, here it is. So this is the emulator logic. And where are we looking for? We want to, when we read a character in the, let's see, that's the core, not the core. We want the emulation. So the emulation, so this was the port write function that we added the Q2, but down here we read we get a character from the keyboard, and we then decide whether it's useful or not in the special function keys that I use to control the playback of the processor. The various single step, halt, run, etc. Run to return is not so great yet, but anyway. So all we end up doing is passing the character on, setting the port value, but in doing so, we don't read it back. So really, what I'm looking for in port write, right now we've been always looking for port number 1, which is the output port, but port 0 being the input port. Every time it reads a character from the input port, it's supposed to set it to 0 to let me have some synchronization. This was needed in the electronic simulation version as well. So we get this output pending. Just jump up there, make ourselves an input pending. It's real quick and easy. I wish I could make it go back to the browse where I was last browsing. It's a feature that Multi has that none of these seem to have ever picked up on. Oh wait, maybe that is. Hey, what do you know? No, that's not it. That's not what I... Is it? I'm not sure which way that button's working. In any case, let's see. Port right. So every time we read a value, we should be writing a 0 back to port numbers. Port 0. We're not even covering it, right? So if a port number is equal to 0, and also if we port value equal to 0, because that's what we told the electronics to do, to acknowledge the character receipt. So that being the case, the input pending is false. And we've already read the characters, so we don't need to do any of that. Now, we need to make this true in our keyboard thread right before we, well, or after we send it in. All right, we're going to make that true. And then to really synchronize it though, I would normally, let's just see. So while this remains true, which we don't have to specifically say is if it is equal to true. Just what this is read as while it's true. We're just going to sit here and spin our wheels for now. And in fact, for that matter, since I don't need to do anything, I'll just end it. So I think it'll work. Let's see. Build solution. All right, so our code so far, not terribly interesting yet, but here's where we tell it we want to get the cursor position by printing a particular string of characters. In this case, it's escape, open bracket 6 and lowercase n. If we send that to the terminal, it will supposedly come back, and actually, I mean, it does. It's just we're not reading it yet. It should, well, we're going to halt there. Then, yeah, all we were going to do is just test that function right now. So, we're going to get the cursor position. We print the command to request it from the terminal. Then it should return something in this format. N and M are numbers, row and column. So we have this nice little block of temporary data set aside for this purpose. And we are going to loop around reading it back in over and over again. That reminds me, I don't really want that. I want to, yeah, I want to call get char into the B register. And what that function does is waits to get a character, acknowledges the character for us, and then puts it in the B register. Then we load up the R. It's actually one of the things I wanted to talk about today. Let me just bring this sort of front and center so it makes a little more sense and we can get a little better shot of it and such. So, I want to explain these lines as if they were C code, since a lot more of you are going to be familiar with C code. So, this first line is defining the name of the function. So, in C, it would be void vt get cursor position, except of course with matching case. So it'd be the name of the function, and then open parentheses because there are no parameters being passed to it, and the open curly brace. Let me zoom out just a touch more so we can get everything on screen. Now then, so the first thing we're going to do is we're going to essentially, this is my equivalent of printf, except it's just print a string. And this is load the address of this particular string of characters, which we defined at the top of the file. So this amounts to printf of vt get cursor position. These two lines. Now the terminal is supposed to come back with this set of information, this series of characters. And then we're going to have to convert those text characters to a number, but we'll get to that. First off, let's see. We're going to load, in this case, the DR register, the data pointer, is going to equal this location in RAM, again defined at the top of the file, and then this is just a label, but it amounts to while statement. Actually, I guess, is that the while or the do? Let's see. This kind of amounts to while get char not equal to character R. So this is what you would look like in C, and the way it works here is we have to first obviously get the character from the keyboard, right? So we have to perform the get char portion. Then we're going to load into the A register the constant, which is the character R. Subtract those two. If you subtract a number from another number and you get 0, the numbers must have been the same. And that's basically how we make decisions in computing. Take two values and compare them to each other. And based off of the results of the comparison, we do one thing or another. So in this case, it's a simple, straightforward comparison to come up with a expectation of 0. So if that's 0, then the character we read was the capital R, and that's the end of our loop. But otherwise, we're going to jump, if we are not 0, further down, increment the data register, load 0 into the A register, store the A register based off of the address in the DR register, which was originally this, but is now the next character over because of this. So once we single step through this, it'll make a lot more sense. And then after we've read in the whole Did I get that? Huh. Of course I see an error in the program, right? But that's what we're doing. We're debugging. So this we got the error. So this is the end. Yeah, we jump because if it's not 0. So that loads 0 into the last character. That's just the null terminator. When we need to, let's see, yeah, we would need to convert them. We need to convert the numbers, but for now we're just printing the string. Yeah, just load the value that we read from the keyboard. Skip that first escape character. And then print out the rest. And then leave the function. And if we had actually gotten the R, if we'd gotten the R, we would fall through this. If we don't get the R, which means we haven't reached that character, we're going to jump down here and we're going to store what was in the B register, the character we just read, and when we do SIB, it'll be based off of this last time. So we loaded that. Come through here. Yeah. DR register should still be correct. So we just store our character we read, we increment to the next location, and then we jump back to the top of the while loop. So let's see it in action, shall we? See if I can get everything on the screen at once. Blah, blah. All right. Recompile, or assemble rather. I keep saying compile. It's just assembly. All right. So here we're at no op. Now we're going to go, so we load the get cursor position command, and then we print it. Oh, come on. What happened? Oh. I know what happened. We're in a convenient endless loop because that flag is never getting cleared. Bother. All right. So let's see. Our value in, we say there's an input pending, and then we wait. And this is in the keyboard thread. And this is happening in the processor thread. Port number 0, port, well, let's just see. I'll run this in debug. Much smaller in debug, isn't it? All right. There you go. We never hit that part. So we're never hitting that. I thought that was in our utility function here. Oops, right there. So there is that. We are supposed to read from port 0. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . If it's anything other than 0, we write, anything other than 0, we come down here, we write the acknowledgement 0, and then we return, Even if there was 0, then just comes back up here. I think I might be hitting a timing issue. It doesn't look like we're ever hitting this. All right, well, one thing we got to do is take all this. Sorry. Just take all of this out for a moment. And just not really do this. Well, that's fine. Not call that. We can do all this. What I want to get to is the prompt. In fact, let's simplify it even further. Bug. Freaking bug. Coffee. Late night coffee. All right, so we're not going to bother with the banner. We're just going to print the prompt right away and debug our keyboard before we worry about complicated commands. vt100. No idea what that is. All right. So get a key. It's supposed to get it and load it into B and then set the port back to 0. So we should get a port right. Oh wait. Not that one. This one. That is not what I wanted it to look like. There we go. Let's just start that over. There we go. We're good to go, relatively. All right. Now any key I push here, J. All right. Port num is 0. Lovely. If port num equals 0, yes, lovely. Port value is 0. Lovely. And we clear the pending flag. And this should be happening on the separate thread because here's where we did all the Q stuff for the output. All right. Port number 1, port value J, this is what I pressed. All right. So Well, let's try doing it by hand. V6N, that's supposed to make it report back. And there's the report back. It's really tiny, but let's see. If I change it here, so behave. 32, 32. Font. Solus. 28-ish. Boldish. There we go. So that works. Yeah. So it is definitely getting cleared up doing that. But calling get cursor position function, which right, we did early on. Yeah. All right. Let's see how that plays. A symbol run the processor, and we hit our halt. Now this and we lock up. We're just locked. Let's get rid of this logo here so that we can see. There we go. We're completely locked up. Oh, headaches. What you do? I'm pretty sure we're locked up in that spot, right? Interesting, though. Like I said, we might be getting into a timing race because I have to single step here. Yeah, because what happens if we just let it run? Yeah, see? It operated. That doesn't seem right at all, but row 10 is correct. Column 100 don't make no sense. But would that be it? Yeah, because we're not getting the escape character at all, so we're missing the bracket. And then we need to end it properly. But apparently just single stepping through, that's just blowing it up. So, go figure. Some days you can't. Oh, there we go. Some things you just can't single step. We run into a timing race and then it gets to be a big old headache. But we can run over and over again test instead of single step. All right. So get cursor position. We don't need this increment. So we'll just print the entire string. Then give it a line feed so that we know where the string ends. Yeah, we don't bother to save the R either, but 10100. Where did 100 come from? It's only 80 columns wide. Plus, that's not what I told it to do. So, or even worse, that's not what I told it to do. I told it to go to 8, 10. It did go to 10. It didn't go to 8. Well, let's walk into set cursor position, because I'm not sure we're converting those numbers correctly. If that's what it's reporting back, that seems odd. So, insert breakpoint, assemble and run. Right. So, oh, that was where I wanted to stop. Whatever. Easy enough to start over. All right. So we halted. Let's bring this back out here. Oh, can't have phantom copies running. Not good for business. Having phantom copies running. All right, and get into the no-op. So we want it to be a column or row? I forget. Anyway, we'll see in a second. But we want it to be 810. Let's call into set cursor position. So A is the column, B is the row. Now what we're doing here is we're copying the command string out of ROM into RAM using the string copy constant. And since I pushed these 2 bytes for the source address and the 2 bytes for the destination address on the stack just before I called the function, I have to delete them from the stack by incrementing its address afterwards. Otherwise, we won't return to the right place. So, oh, don't give me that. Let's finish correcting the stack. Now we're going to get the address of the R, our row, which is loaded into B10. Our row supposed to be 10? Yes. I'm not crazy. I just looked that way. Alright, so we got 10, 10, right, so this string should, oh, here we go, here it is. So it's bracket 3 digits. Let's just see. So we'll add 2 to that address. And that should be pointing at this character right here. And then we're going to, we've loaded our row count into B, and we have changed our address to point at this character, which is what we're showing here. And then we're going to call this function that's supposed to convert the binary value of A into 0, 1, 0, 4, 10. But apparently it's doing 100, I think. So let's run into that. So the first two things we do are store our address onto the stack. We store the value onto the stack. Then we load 100 into A, and we divide B, which is the number we're looking at, by 100, which should be 0, right? So let's step over that. Sure enough, the result is 0. Now, we really only care about the lower byte here in the results. So we're going to load that into A, and then we're going to load the address of our little output string. Let's see, that's not all the way loaded yet. Now it's loaded. So now we're looking at our string again, this first character position. We're going to store the binary value 0 for the time being. I think I already see the problem. But now we add 100, put 100 back into B, multiply it by 0. That gives us, oh, let me jump out of that. That gives us 0. And then we take that value, store that into B, then we get the value, the original value we're looking at, which was 10, A, and we subtract those two. And the point being that if we have a number, it's going to be somewhere between 0 and 255. So if we take any given number, you divide it by 100, you get the hundreds place, basically. And all of the remainder goes away. Now you multiply that by 100 again, subtract it from your original value. Now your original value only has the tens and ones. Then we can divide that by 10, and then we have our tens place, do the same thing, subtract the number of tens, and then we have our ones. And that's the process that we're going through here with absolutely 0 comments, because that's how we roll. No comments for you. So now we get into the tens place. I load B into A because it's a division. The divide function is divide B by A. Now we're gonna divide those, and we get 1 with remainder 0. And we're going to get our, let's see, LBM load B for memory. That is our output pointer. Oh yeah, this is setting up our output pointer again. Now our output pointer is looking at this first character. We turn that to a 0. Now we're looking at the next character over. We're going to turn that to a 1, which isn't the same thing as the 1 that you draw on screen, but it's 1 numerically. Then we're going to load that 1 back in, load in 10, multiply those together to give us 10. Then subtract that from our original value, which happens to be A. So we end up with 0. Store that back. Again, setting up the output location. Again, we're still pointing at this first one, so we have to go to the next and the next. Now we're going to store the 0 there. So that's 0, 1, 0. So to do 10 correctly, now we have our, yeah, that's all of our ones. So this looks like we're doing this a second time when we don't need to. Oh, no. This is what we're doing. So now that we've converted them, we've figured out the number of hundreds, number of tens, and number of ones. We need to convert those into characters that we can print here. And we do that by adding 3 0 to each one. So set up our pointer again. So we're pointing at that first location. Load that value into A, load 30 into B, add them together. You get 30, put it back here, so our 0 becomes the numeric, goes from numerical 0 to text 0. Increment our pointer. Load A was 1. B still 30. I guess I don't need to keep loading 30 into B, but sum them together. There's our 31, so there's our text 1. Increment to the next location. Load 0. Load 30 into B for a third time. Sum that together. And store that back. So there's our 10. And that's not what we got before. But we got an 8. We should get an 8. Maybe I got these backwards. But anyway, let's continue. We're going to clean up the stack and return from this function. So that was this conversion for these 3. Cursor position R. Oh. I read it twice. That, I don't think that was supposed to be, yeah. Load the C value. That's not a C. Well, there's your problem. Probably. Anyway. All right. Save that. Be done with that. Symbol runs more. Yeah, let's just run. Yeah, there we go. 10.8. That's what it was supposed to be. So, or rather, that's what it read back, or played back. So, V bracket 6N. I don't know where the second semicolon come from. That's really weird. What will we need to do? All right. Yeah, well, I'm all on that. Let me show you the other thing I got going here. So, we already have our basic controls, like clear the screen, print the ASCII table, and send a VT command. 3296 M. There we go. Ain't that pretty? Now, we also had added to the test, we now have our box characters. that we were playing with earlier, or last time rather. And what I realized was, regardless of which types of box we have, either the double line or the single line, these all just amount to an array of 3 characters for each segment. So there's the corner character, the middle character, and then in the middle row there's the 2 side characters, and then on the bottom there's the 2 corner characters. Well, what this led me to, of course, is to create a whole character set, or a whole set of numbers. Here we go, 0, 1, 2, 3, 4, all using these box characters. And it's kind of fun to throw back to what I did probably, I don't know, 30 some odd years ago. And then I added a few extra characters so that I can change the banner up. Put EUP5108 in those characters. So just to show you a bit of that, these are the box character digits. And I picked out all of these characters using the ASCII table here, and then just block and copying the characters over to here, and then their character codes. And these are set up right now to just print and, you know, carriage returns on each line. But I'm going to eventually change it to where these are, they're going to have cursor position commands for each beginning of each row. But really what I wanted to do was set the cursor position to wherever on screen, and then say draw the box. And it would read the cursor position back in first, mostly so that I don't have to constantly send that information around, because it's already known, it's already being stored here in the terminal. But in any case, we'll get to all that. And then in the box drawing characters, that's down here. Oh, that's box drawing digits. Here's box drawing characters here. So the double line matrix box and the single line box are just these 3 characters for the top, middle, and bottom, like I said. So I think there's also, let's see, what do we want to do? There was a double top row box, double side single top row, single top and bottom. So let's call that, I don't know, the single line for the top and double line for the sides. So we want these to be, we want to be looking down, skinny, and interfacing with, so we're going to need that one too. Let's take that one. That one, yeah. So that'll be that character. And that was, I already dropped it, dang it, B8. This single character CD. And then the other character here, it is this one, DA. Oops. DA? No, not DA. This one, D5. Oops. So, hi everybody on Facebook too. We got everybody going here. X, Facebook, Twitter, the whole 9. So now here's D4. Sometimes I have no idea who decided what order these were going to be in. They don't make any sense to me, but eventually you can find what you're looking for if you stare at it long enough. So D5. This CD right here. And then one last character. Where'd you go? Where'd you go? Don't everybody scream out the answer at once. There we go. Looks like, yeah, a single on the side, so it's going to be BE. So the box drawing logic is to draw the first character, then the second character, however many times wide you want the box, and then the last character of the top. It is then to draw this center line over and over again, also repeating that pattern, but for however many times tall you want it. So the dimensions are actually the inside dimensions of the box. Although I guess I could have subtracted them in the, but you know, it's just extra code. When I can just understand that the boxes are drawn internal dimensions instead of external dimensions. So here's our single line matrix, double line matrix. Let's get the other thing, matrix. And let's make this one that. And we don't need to be 78 anymore. Let's maybe like 22. There we go. Symbol will run some more. And come back to this. It's just sometimes the problem becomes annoying and we just move on to some other things that we wanted to get done anyway. Ah! My box is wrong. Wrong, wrong, wrong. It's so horrendously wrong. It's ugly. Don't look at it. Don't look at my ugly box. But look at the pretty numbers. And a few letters. Anyway, so that was the wrong character, yes. Is it the wrong character here? No, it is not. It is the wrong character. Yeah, it was D5, which is the top one. Which is not it, so what is the character I do need? Move that up to where everybody can see it. I needed D4. Why it slows down sometimes. There we go. Here's our lovely box. They're double lines. Let's see. After this, we can actually tell it to move up one. Well, let's see what it looks like. Let's play around with this for a bit, because that's what we're doing. All right, don't need this anymore. Not for now, anyway. And let's see. Let's make this only one. Let's see what we got. H-A-O-W-O-R 10, let's make it like 12 inside, why not? We're going to draw that multi-line box. And let's comment these out for now. So what I want to do is kind of make this as a display. So we'll need to move up a character. Script. Oh, that's a scroll. Yeah, VT up. So we want to go up one line after that, and then one more. Get back inside the box. And then we want to move over a touch, just a scotch. So we're going to move to the right. And I could modify these to where they go some particular amount instead of just always one each, but me, you know, I'm gonna shortly have a generic set cursor position, shortly. But if you don't know where the character position is, or you don't want to sit here trying to figure out where exactly I put the thing, because you know this was line 8, 9, 10, blah blah blah. So these are just relative positions, so it's easier. So we're gonna do all that, and then after that, let's print the hello world, shall we? Where's the strings? There we go. Always good to have a test string in, right? So let's define string hello world, and it is the string hello world with a new line and a terminator. And do we want the new line? See, now that we're moving things around on the screen, we probably don't want to use things like new line so much because, you know, say we print this in the middle of the screen, we use new line, the cursor goes somewhere else where we don't expect it. So really it's just excess bytes for us. Right now, should work. Actually, let's see, if I give it 2 new lines, then I think it will come back out from the box and the cursor or the prompt will be under the box. So I'm trying to make this a one line or one thickness box, print hello world in it, and then have hello world in a box. And then, then this prompt come out underneath that. So we got a new hello world string. String 1E. Symbol. What do you mean undefined symbol? What? 292. Yeah, that's where it's complaining. Oh. Save your files. Must save files. They're all saved now. Must save your files before running the assembler. There we go. Test. Yay! What do you know? We got a nice little hello world in a box. That was one goal. And then our big numbers got printed underneath that, which was the other goal. And there's our prompt. Cool. All right. So we're gonna display. So we got, let's see, we got box characters for drawing portions of the scoreboard. We got big characters for big numbers on the scoreboard. I kind of wanted to do the traditional 7-segment display, but then, you know, we have all these extra little characters that allow us to make it more interesting, like those. All right. What else? Other assets do we need? We already have the ability to move around the screen using the WASD characters. Showed you that last time. Change colors and so forth. That kind of fun stuff. So we have cursor movement, cursor control. We have large font for scoreboard and some box characters. Now we need to create some bad guys and some good guys. So we're going to create the bad guys and good guys out of the various characters we have available. Whoops. Using that terminal, so let's see. Let's see what kind of bad guys can we create. I kind of like the less than, greater than. We can kind of get a sci-fi kind of spaceship looking thing. Let's see. All right, I like to do that to this top of the page here. But let's see, we have like we got here. We got the greater than, less than, 3C, 3E. There's equal sign in between, so we could have one kind of bad guy and just be just kind of be that character set, character combo, or an equal sign. Well, that kind of looks like a puck of some sort. So we could have a, you know, varying size paddle. And, you know, I don't like the way they're dashed together. So we could do, let's display, let's see, 3C, CD, 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 and 3E. So that way they're all connected together, see? Let's see, what other kind of things could we make? Of course, we've got these big block characters. Those can always be used for showing something that's degrading, right? So we would start off with that kind of character, right? And then as things got worse, right, we would go from DB to B2. Oh, that's interesting. I didn't realize B2 wasn't covering the whole square. I didn't realize it was shorter. Huh. Anyway. And then we've got, of course, we can build with these building blocks. We can build just about any kind of block shape that we want. but that's not as interesting as some of these others. Yeah, like F2 and F3 here. F3, CD, F2, sounds like a song. That's not too terribly interesting. What if we tie that together? Let's see, we could do like a, well, kind of like the bottom of my number. So we could have, what do you call it, like a D4, and then a CD, and where'd you go, where'd you go? You're around here somewhere. Yeah, I might have it here. More readily seeable here. Yeah, like the bottom of my 1. There we go. So this is the bottom of 1. D4, CA, BE, D4, CA, DB. Oh, that wasn't it. D4, CA, BE. There we go. That looks like a crown or something, right? Very interesting little character. So, I don't know. We can draw all sorts of things. I have to think about it. Wonder. Yeah. If we're gonna do like the breakout game, you know, we need a lot of solid characters. So then we can have a bunch of walls of DVs. And then a D0 here, and some more DVs, and a I know it sounds like an odd thing to be saying, but anyway, there you go. You got a doorway and a wall, or, you know, one of the squares that gets blown up. So we start off with a nice solid square, right? And then it gets hit once, it comes that, hits again, and then hits again, and then after that it goes away, right? That's basically breakout, right? And then we could do things like be kind of hard to do colors here, but and what am I looking for? This thing that looks like a fence, sort of like a fence or a gate. It is around here somewhere, maybe D7. Yeah, there you go. There's another kind of door. Care. So, we got all sorts of things to play with. Let's see. I have no idea what that symbol is. Oh yeah, these ones look like they're just pre-designed. I mean, I'm sure they're mathematical symbols and so forth, but they seem conveniently designed for something that might be changing shape as it moves across the screen. So we get something with the, let's see, we got F3, and you can imagine E8 and E8 and E9 oscillating between each other. And then we would have F2. So if you can imagine these two symbols kind of alternating back and forth. That might be an interesting little character to crawl across the screen, eh? Let's see. I keep switching back and forth between like block out or breakout and like a Space Invaders. I don't know. Space Invaders is somewhat simpler because the bullets just go up, right? The bullets don't bounce off of walls like breakout. Yeah. I don't know. Maybe we'll stick with something more Space Invaders. So if we're gonna have Space Invaders, we gotta have something with a gun, right? It's gotta have a cannon. And these kind of characters make for a decent looking cannon. We got CA. And then what's a D? D is just my command abbreviation for display the following hex values. And D5 and CA and where'd it go? Where'd it go? Where did it go? Looking for a character. Do-do-do-dee. It's around here somewhere. Oh, oh. I'm telling you, you're making me deaf with all your suggestions. B8. There we go. There's our little guy. He looks like a decent little cannon, don't he? Let's see. So put a character turn on him. And then the next ones. Let's see, the next character would be something. I want him to be a single line. I don't know. Let's see. D8. D8. There we go. Maybe. I don't know. D8 looks like a good little bullet, doesn't he? D8 is a bullet. This sequence is my bad guy. Is my good guy. Let's see. Good thing I'm recording all this because I don't have that much screen space. Let's see what else we got. That would be our good guy. We got our bullets. We got a couple of different bullet options. We got just F9, right? It's D, F9. We fate. We E9. There we go. Pew pew. Pew pew. I don't know. We'll use something like that. Maybe our good guy shoots infinities at people. And then our bad guy shapes, you know, like, I don't know. They're going to be mostly blocks. I don't know how interesting they are, though. They were the shields that you hid under, right? So shields. Shields are going to be something like 20 dB, 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 20 away, then dB, dB, and dB, and that one too low. I think I got that right. Yay, there we go. Here's our shield. Or a start of one, anyway. And what else we got? The shields, we got the bullets. We got our good guy with a gun, or a cannon. Hey, everybody. What other shapes would we want? Shield, cannon, bullets. And one bad guy. We need more bad guys. Or it's just kind of like a spaceship. Those guys. So I wonder if we can make a little man. Like a little alien guy out of these characters. You know what I think I'm going to do? I think I'm going to print all of these characters out on a sheet. Where I can just sort of move them around like tiles or something. Because I mean, even this seems like so much search and replace. Maybe I can just move them around like tiles. That would probably be better. I think I might try that. Wish I could figure out the pattern. I mean, I know the C's have this single thickness walls, B's and C's, and then there's some double thick walls. I never did figure out this pattern, but anyway. Well, you know, the other kind of game we could do. Think of all the different games we could possibly do and not build any of them, right? But anyway, one of the other games we could do is kind of like pipes. Like we could just use these kind of characters here and you could draw pipes. You know, I could probably do that to the Etch and Sketch game. I can expand the Etch and Sketch game to cycle through characters. I could kind of draw pipes, I guess. Pipe Tetris, where any one of these kind of pipe characters coming down the line next, and you got to keep the pipe connected. See what I'm saying? So how would we so yeah, you'd have to have some time limit to place the pipe, the next pipe segment. I don't know how I'd figure out which, if you kept the pipe segment open or something, but anyway. We could do something like that. Just think of all the possibilities. Let's see what A9AA together looks like. And they don't quite meet up. Darn it. Let's see what else we're doing. Should I go back to the other problem? Let's go back to the other problem. Which was that we were setting the cursor position, but not getting the cursor position. Or rather, we were getting the cursor position. We weren't converting it back to numeric values. Set cursor position, get cursor position. So right now we just grab it all in, we print it out, carriage return on it. So when we run, get 10.8, and then that second semicolon, where is that coming from? Because the command itself is supposed to echo that. Where in the world is that second semicolon coming from? So this is 7, 8, 9, 10, 11, 12. So right after I hit carriage return, that's what it's reporting out, was this location. 12 ones. So we have to do an ATOL, or from ASCII to a long value, which I think I have that. So what we would do is we'd get this string back. We would start at this location. Well, we'd have to come along here. If we converted the semicolon to a 0, then we could convert this string, which would just be that, into a number. It'd be convenient if it was always all 3 digits. It's actually always 2 digits, really. It's 80 by 32. I guess in the scroll buffer there might be more lines, so maybe that's why it's up to several hundred. Or, you know what I could do is parse this bad boy out as I go. Instead of just sticking it into one big string and then printing it. I know that the column is going to start, or yeah, there's a column. No, it's row column. So the row is going to start after that character. So let's create a second temp string, or a third. Yeah, let's create 2 other strings to put this in. Do I want to do that? Maybe. Maybe. Let's see. Now the question is, do we want to do it in this function? I say yes. It's only 4 characters each. 4 characters, that's a lot to shove on the stack and take off the stack. So I'm going to cop out and go with a couple of more global strings. Don't at me. I like globals. And in this sense, it's not all that wasteful. Let's call it vt row string. And we're going to give it all 4 characters. And we're going to declare another variable, vt column string. And it's going to be a size of 4 characters. So if you were writing these in the C language, it would be I probably wouldn't use the period, but in any case, you get the idea. And that this is 20. Same kind of thing with this. But only 4. And they're just globals, because it's easy. And, you know, we're not doing a bunch of add-on programs that are going to desperately need all that space. But let's see. To begin with, we're no longer going to be reading into this. So we throw away the escape. We want to read it directly into the row. And we're going to specifically call this twice to throw away the bracket. All right, so that throws away the bracket. Hey there, new folks. There's a few extras showing up. So that just read it, toss it, read the next one. It's going to be the first of our row number, right? If we get to the end, then we're done. And I do want to load the Z, but also for that, we want to compare it to the semicolon character. And if it is the semicolon character, then we want to change what we're looking at here. So the semicolon, well, yeah. So if it is the semicolon character, we're going to jump if it's a 0, if it's not 0, to vt get cursor position dot Mr. Why not? And you know, let's do this up here. Let's do this, or rather, let's do it after the check for the end of the sequence. And I can't do that twice. If I want to do this to throw away the bracket, I'm going to do that up here. And that throws away the bracket. Here's because that's the top of our loop. We get the character, it is not the R, or rather, it is the R. So we increment and put a 0 in. That'll be the end of the column though. Right now we're reading a row. Conversion, just doing the print for now. So we're going to print the row. And then print the column. So we're going to print them out, and that'll show us how we're doing, making sure we get the parsing correct. If we do that, we end. Print them all out. Otherwise, we're going to get more. So now we have to make sure that it is not the semicolon. So if it is the semicolon, semicolon, jump long if not 0, and that will be vt get cursor position dot, I don't know, it's, so it's still, we haven't got the semicolon yet, then we're still in the next row, right? Yeah. Let's just say it's no semicolon. Give it a name. Why not? If it is the semicolon, we fall through that. And what we want it to be is, what we really want to do is change this from the row to the column. We should put it at the front of that string. And so we load that up because it's a semicolon. And we don't want to store that semicolon. We don't want to increment. So we're just going to run back around. So first off, it's going to look a little squirrely code. Oops. All right, so explain how this works. So here's the top of the function. We load up what it means to get the cursor position. We print that out. The terminal echoes back some value. We're going to load up the row string. Throw away that bracket character. Then we're going to get the next character, which should be the first character of the row. We're going to see if it's the last character in the sequence, the R. If it is not the last character in the sequence, we're going to jump down to, we're going to jump down to here, the GM, which is get more. So it is then going to see if it is the semicolon character, which ends the row. If it is not the semicolon character, then we're going to jump down here, store it, increment the pointer, and go get the next one again. So we go get the next one by jumping up to here, get the next character. Is it an R? No, it is not an R. So jump down to here. Is it a semicolon? Let's say it is a semicolon. So this fails through. We load up the column into the DR register instead, and we go get another character. And that looks like it should work. And I hope so, because I can't single step through it, because it won't let me single step through it. We lose the characters. So let's give her a shot. Oh. Get out of that. Oh, VT call that string because it's capitalized. Line 166. There you go, 10 and 8. We have successfully parsed the string. Isn't that lovely? We now have two strings, but have the two numbers. Now, I think, maybe, I already have a function that'll turn that into a binary. I thought I did. Stringlib ATOL stretch that open a bit. So we point to a string of characters, a 2-byte, put the results into DR. Assumes the string only has 0 to 9. Alright, we did this some time ago, but now what is all this comment at the bottom? Oh, row. That does not look like it is complete. I'll copy the string address. Local accumulator. LBI. What the LBI? Oh god, this code's so old. I think it had a different instruction set. No, there's never LBI. There's next to no reason you would load directly into the instruction pointer, but it's capable of it. It's a good way to get your code flying around in circles. So this is never going to be the thing. If it's supposed to be that, that is LB for memory, LBM. Maybe that's why I had trouble figuring out what was going on with this. So let's see what all we want to do here. We got alt for debugging. We create a source variable. We stick that source variable on the stack. Our local accumulator, which we initialize to 0 by loading A with 0 and pushing it twice. And why is that 2 and 4 though? That should be This should be like 1 and 3. Hmm. Hmm. Looks like I left myself some notes and then just ran off and didn't finish the function. That just like me. Hmm. Well, let's see. We would, because we don't have a fixed set of characters, it's not 3 digits always. We would read the first character from a string, yes, and convert that to a value, store it in our local value. Then we would read the next one if there is one. But so if we read the next one, it's not a null, it's another character. We convert its value. Then we have to read the previous value out, multiply it by 10. By 10. You know, this function's been done in the C code forever. Let's go see what it looks like, yeah? See if we can find the C standard. TOI actually, L for long, but just examples of use. I don't see in the source code for it. Let's see, here's from gitlibc. Oh, that's not very useful. It calls stripl string too long. Let's see. Oh, that's just the headers. Search for function. Oh. str tol weak alias. Okay. Double underscore. Oh, Jesus, complicated. Well, this isn't going to be any help. So yeah. I think this would be a standard example somewhere too. Someone's bound to have needed to do this before. Could we do it sort of backwards? So here's the conundrum. So we have just a character, and then we could have, you know, like that, or we could have 233. I mean, again, it's only going to be double digits probably, but might as well make it all the way up to a byte. So I could read the 1 digit, right? We read the first digit. If we convert that from 3 to 3 binary, and then if I read the next digit, so if there's no next digit, it's just 3. If there's another digit, it's be 2, then there's got to be a simpler way of doing this. Maybe we work backwards. Yeah, it's probably going to be easier if we work backwards. So we're going to go to the end of the string. We're going to look at the character at the tail end first. And we're going to say that's got to be the 1's digit, right? So that value is added to the accumulator. Then if we have another character, then we know that that is going to be the 10's digit. And if we have another character, that's the 100's digit. So it's probably best to work it backwards. And could we parse it in backwards? We might be able to parse it in backwards. And we don't have to reverse it. So as it's coming in here, yeah, you know, we could do that. Instead of starting at the beginning of the string and bringing in the characters, we start at the end of the string. And instead of incrementing, we decrement. And we get the characters in backwards in the string when they're in string format. But that means the first character we look at is the 1's, and then the 10's, and then the 100's, and it's much more straightforward to convert from text to number. So let's do that. So first off, we're going to load that up. Then we're going to load in the size, and we're going to sum those together. So that adds 4 to the pointer. That puts us at our last location. We're then going to be decrementing that pointer as we go. Same here. When we get to the row, 4, add to that. Oh wait, this was printing them out, so I don't want to do that when I'm printing them out. Down here, once we recognize where we've got change, UDA, there we go. So that has us loading the column, going there. That's the decrement that's doing it anyway. The Annoying. So when we print a string, we want to print it. So we don't want to do 3. Actually, we want, yeah, load that, add 4. Let's add the pointer, add 4 to the pointer. Load 0 into A, and store indirect A, and decrement the pointer. So what that does is it loads up the starting address of our variable, adds 4 to that address to get to the end of the variable. That's the addition. Then we put 0 into A and store A there, and that puts us null at the end of our string for us, and we're starting 1 character back from that. And so we kind of need to do the same thing when we switch over from getting a semicolon. There we go. Looks a little more complicated than what it would have been originally, but this should put it in sort of a reverse Polish notation where the numbers go in backwards and the operations go in backwards. Or rather, you put in your numbers first and then you say the operation. In this case, we're just inverting the order of the characters so that the conversion will be easier. And it'll be sort of a non-standard ATOI because it's not how you would normally interpret a typed number. You should probably have done it that way, but anyway, whatever. Let's see how it goes. So we're not going to do the ATOI yet, but we're just going to see if we manage to reverse the order of the printing. Command loop in A, out of range, line 33. Eventually just give up on the short jumps. A short jump is staying within the same page of memory and jumping plus or minus, or jumping around within that 255 byte page of memory. But every time I add code here or there, move things around, and then suddenly the destination is out of range. It's no longer in the same page. And what the short jump should be is a plus or minus of the current position, and that keeps your code nice and portable. Because a jump like this, which is what, 3 instructions away, doesn't need to take up 2 characters. I should be able to put a relative jump. But that's not the way the short jumps are operating right now. The short jumps operate by just replacing the lower byte. Saves literally like 4 cycles or something. And it's kind of annoying because I occasionally have to go out there and fix them like I did there. Oh, well, something didn't work right. That's annoying. Get cursor position. So what happened? We only got the 0. That's no bueno. So we get the row. We had 4. There's the. I'm adding 4. Decrement. So it's at the tail end. Throw that away. get the next character. If it's not an R, go down here. It's not a semicolon. Oh, there it is. I need to use that for decrementing again. Lovely, it printed a whole lot of nothing. You know why it printed a whole lot of nothing? Because all of those characters were 0. And leading nulls. So the string just immediately stopped and didn't print. So to see this edit, I think I'm probably making this worse than it needs to be. But we'll see. Let's see. Well, this may only work the first time through, but yeah, let's do it before all of this. What we're going to do is pre-fill the string with spaces so that, because I'm filling it from the tail end and the front ones are 0, and so it prints and says, yeah, they're 0, so it doesn't print anything. So that's why let's just pre-fill them with spaces. And I don't have a particularly good function for that. So we're just going to define a space string, and that's going to consist of a string, not a string, but literal characters of 4x20, which is space character bytes, and then a 0 at the null terminator. And then get far more complicated than it needs to be, I think. But we're going to put that on the stack, and put that value on the stack. Then we're going to call string copy constant. And if I remember right, I don't remember, of course, offhand. If string copy constant, what the order of the should be destination source. String copy constant is destination source. Push source. Oh, so string compare. String copy constant is destination. Push the source address, then the destination address. There's our source. There's our destination. We copy. And then we would normally clean up the stack completely. But if I just increment it twice, and then load that, and I can put that back on the stack. Call the copy constant into the other destination, and then here we would so every time we push something on a stack, we decrement the pointer, and that pushes it from the top of memory back down towards the bottom. And everything we do in the code, we do from the bottom up. Hopefully they never meet. But that's why you see the stack, when we push it on there, we decrement the pointer, and when we pull it off, we increment the pointer. We don't so much pull it off as we just move the pointer ahead. We leave the data there where it was. So that seems like an awful lot of complexity just to fill our string with the 4 blank characters. 4 blank characters should be 3 blank characters. And actually, considering that I did this, I'm doing it every time the function's called, I do not need, I can just add 3, and we don't need to do that. Same down here, let's just add 3, and we don't need to do those 3. All right, optimizing as we go, always a good thing, right? Sure. All right, well, we got 01, which is the 10. What happened with the 8? Well, we can't single step through it, but we can stop it when it's about to print and see where we got. Here's where it's about to convert. Let's put a halt there. All right. So now, this is where we're about to print them. So this is what we should be able to see them in memory here. So here's our 8. And our address, 61. We got 234. 2, 3, 4. Didn't get the 20s. And that should have been correct. Let me walk through this part too, because after we send this string out that we can't walk through it reliably. Yeah, looks like it's coming up on the late nights. So I will continue with this. We will get some updates to you shortly. And be sure to tune in next time. And thanks for joining us, and we'll see you next time. Just let me know what you think down below. Be sure to like and subscribe and all that fun stuff. And be sure to check us out on all the other platforms that we're trying to stream on all at once. And, push the like button, all those kinds of fun things. And we'll be seeing you next time. Bye.